All right, 111. I get ln base 4 x minus 1 equals log base 4 x minus 2 minus log base 4 x plus 2. And so working this out, I need to solve it. So I want to get everything down to 1 log. So this is going to be log 4 x minus 1 equals quotient over here. And now, because I have the same log on each side, I can set these values equal to each other. Now from here, I can use cross product, clear the fraction, however you want to think of it. So I got to multiply these two together. So I'm actually going to FOIL those together. So it's going to be x squared. It'd be a minus 1 and a positive 2. So that'd be plus 1x minus 2 equals x minus 2. Right? So that's if I multiply these ones and these ones. Right. And so it's a quadratic, so I'm going to set it equal to 0. This actually came out pretty nice. And then x squared equals 0. Okay. So we'll take the square root of both sides and x equals 0. Well, you go, all right, well, I got a bit of an issue here because if you look at the original question, the highest power was a 1. So I raised the power in this process here, so I could have created an extra solution or no solution. So I got to go back and plug this in. And if I plug in a 0 right here and right here, I'm going to get negative numbers, and I can't do that. So the answer is no solution. 113 is log base 10, 1 minus x equals negative 1. So I want to go ahead and get rid of the power or get rid of the log. So I want to put everything on a base 10 or raise everything up onto bases of 10. So I get 1 minus x equals 10 to the negative 1. Okay. And then I can subtract a 1. Then divide everything by negative 1. And coming over here, x would equal something like positive 1 minus 1 over 10. Punch that in my calculator. I should get about 0.9. Okay, 127. Okay. And this is a word problem. So this is another situation where they're not giving us the k value for this exponential model. So we got to find the k value and then eventually try to answer the question. So let's take a look at it. So it says the population of Dallas in North Carolina between 1990 and 2008 can be modeled by this particular function. Okay. This is in thousands. In thousands. Okay. And if I say t equals 0, that corresponds to the year 1990. Okay. In 2008, the population, so there's a time, there's a P for an output. The population in 2008 was equal to, that was about 9 million. Okay. They want to know what's K and what would the population be in 2020. Okay. So I need K to figure that out, right? If I knew the K value up here, I could just plug in, into here and get it. Okay. So looking at 127, the one thing I got to be careful about, this is kind of confusing, is a lot of the examples we did in the book were different, but 0 doesn't correspond to 2000. It corresponds to 1990. So if I wanted to plug in 2008, that is really 18 years. So for me to rewrite this into the function, I would actually say t is 18, right? Because I started from 1990, not from 2000. And my output would be this. Okay, so that's what I'm going to enter in to find k. So I'm going to say 9222 equals, I don't know k, but the time would be 18. All right. So I'll start to solve this. So I'm going to divide here. All right. Then if I do that, that's about 1.37 equals e to the k. I'll put the 18 out front. Take the ln of both sides. That way I can get rid of that power there. Okay. And so then I'll take the ln of that, get a decimal. All right, and that comes out to about 0.318 equals 18k. Remember, those are inverses right there. Then divide by 18, get that k by itself. And if I do that, after dividing by this 18, k is about 0.0177. So there's my k value. Okay. So I got to clear the page because I ran out of room here, but just remember that's my k value right there. Okay. So now I can rewrite it and say P is equal to 6707.7 e to the k value, which I just solved for, 0.01769 about, and then t. So that's my usable function. So now I want to find 20. I want to plug in the year 2020. Okay, so remember, 0 is actually a 1990. So that's really for this. I'm going to enter a 30 because I got to start from 1990, not 2000. So I'm going to plug in that. And then from here, it's just all calculator work. Okay, enter that into my calculator. So the best way to do this is start with the E. So the E would be 0.01769 times 30, and then times 6707.7, okay, and that equals